This is Earth and this is Mr. Barry. What if Mr. Barry jump up? Will he be able to make the Earth jump down? Yes. Let me show you the physics.
Solve this problem once again. So this is the scenario. All right. So this is the scenario, and what happened over here is Mr. Barry is off the ground. How much? Maybe 25 centimeter. And Mr. Barry is accelerating over here. How long he has been accelerating? Okay, let's say 0.35 centimeters. 0.35. Okay, so what does that mean? That means you have the crouching. So let's call it A, let's call it B, and let's call it C. All right. So the crouching takes place how long? 0.35 meter, and then in the air, how long Mr. Barry has been in the air, how long he was in free fall, how much did he jump? 0.25 meter. Those all are the same language. All right, so make sure we understand other thing. The velocity at A is 0, velocity at B we're going to find it, and velocity at C is also 0 because it's at the max height of the parabola. So let's see, let's find the velocity first. So Vf squared is equal to Vi squared plus 2AD. We're going to do it for parabola. Write this one. So then BC squared, BB squared plus 2 negative 10, and D, don't forget D is 0.25 because we are using parabola. All right, so C is 0, and so 0 is equal to VB squared minus this is 5, so this is 5, so minus VB squared is equal to minus 5. So V is 2.24 meter per second. So that's the velocity, launching velocity. During the launch, that was the velocity. All right, now let's find the velocity right here, the velocity, launching velocity. So let's use the velocity to find the acceleration. So Vf squared is equal to Vi squared plus 2AD. So now this one Vf is now V is the Vf. Is now A is the initial. So at A velocity is 0, at B velocity is 2.24. So there must be some acceleration between these two. Otherwise, how the velocity jump from 0 to 2.24? So there must be acceleration, and that's what we're trying to find. So acceleration 0.35. Okay. So this is 0, so B squared is 2.24 squared plus 2 times A times 0.3, okay, 0.7 A. So A must be 7 meter per second squared. All right, now let's find the free body diagram. So let's say this is Earth, and this is Mr. Barry on the Earth. Okay. So Mr. Barry, in order to at B, even B, Mr. Barry had to push the Earth in order for Mr. Barry to jump up. So push, Mr. Barry push the Earth by Barry. So the force Mr. Barry apply on Earth. Okay. So, or you can say this is push. App push, but I'm gonna do it in terms of Newton-Third law. Newton-Third law acting on two objects. Understand that is a closed system. The system has only two things. One is Earth itself, and one is Mr. Barry. Okay. So then, if Mr. Barry apply some forces on Earth apply same forces on Mr. Barry. So Earth applies same forces on Mr. Barry, which is equal in magnitude but opposite in direction. Make sure those arrows are equal in magnitude. Okay, so how much is that? So this is easy to find. So this is m g plus a. We already have m is 70, so b, so 70, and we already have g is 10, and we already have 7, so this is how much? 17 70 times 17, so 70 times 17 is 1200. So this is 1200 Newton, so this must be also 1200 Newton. Don't forget that there is other force acting on these bodies. Force, the earth pulling Mr. Body to the center of the earth, which is mg. 70 times 10, which is 700. I want to call it Fg. Mr. Body is also pulling the earth to the center of himself. I want to call Fg upward. Okay, so now we have enough information to find. I'm going to make this one the blue. So this one, I'm going to make this one blue, and this one blue. I'm going to make this two red. All right, I'm going to make this two red. Okay, so now let's first find the net force of Mr. Body. Net force of Mr. Body would be sum of these two vectors. So F net body would be sum of two vectors. So how much? This is 1200 and this is 700. So 1200 minus 700. 1200 minus 700 is 500. So I'm going to just write 500. All right. So F net, so now acceleration of body at location B, just the moment of the launching or jumping up, is of course F net, which is 500 divided by 7. So acceleration is 500 divided by 70, which is mass. So 500 divided by 70, which is also 7 meters per second square, and that makes sense. Here you have 7. Okay, now let's do the earth. F net for earth. Here, this is the sum of these two vectors, these two blue vectors. The sum of these two black vectors is also gonna be 500, but rather negative 500. Divided by the mass of earth, 6 times 10 raised to negative 24 is 5.99 times 10 raised to 24, but positive 24, but you can round it. So this was F net Newton. Now find the acceleration on earth, that moment when Mr. Body jumping up with the acceleration 7, the earth jumping down with the acceleration, let's see how much, minus 500 divided by 6 times 10 raised to 24, and that is, I will say 0, because this is going to be negative 8. I'm not going to put negative 8 times 10 raised to negative 23, I believe, Newton, down. Okay, so instead of putting negative, you can put down, but you can put negative, it doesn't really matter. Alright, so earth is moving downward. It's a number. It's small, but it's a number. Hopefully you understood this problem. Make sure you have a good understanding of this problem, because you're probably going to see this problem in the